Assalamualaikum and very good morning. So we continue our topic for the conditional and absolute convergence. How we can identify or categorize that the series is the conditional and absolute convergence. Okay. So the series we can call as absolute convergence is the sum of the series absolute series is the convergence. Okay, and AN is the conditional convergence if the absolute value of the series is the divergence. Okay, so that's mean when you sum of this this series, the answer is not converges. Okay, so this example determine whether each of the series is convergent or divergent. Classify any convergent series as the absolute or conditional convergence. Okay, so this one kita dah buat sebelum ni. So this one adalah convergence kan, is it? This one alternating, so alternating. So you need to limit 1 over set n and find the either the set n plus 1 must be less than, so this one 0 and 1 over n, so this one adalah convergence. So we need to find either absolute or conditional convergence. So we put the absolute value and then we plus we expand. Okay, and then we found this one is the P series. So they equal 1 over n P. Okay, so and 1 over n P, so P the 1 over 2. P is the 1 over 2. 1 over 2 is the less than 1. So here this one series adalah convergent. Okay, the series is the convergent. Bila convergent, so this is the conditional convergent. Okay, so this one for this one. Okay, so the geometric series. So geometric series, and this one settle alternating geometric series, you need to look at the R. So R the 1 over 2 less than 1. Okay, less than 1 is the convergent. So here adalah absolute convergent. Okay, this is the way how you can determine either the absolute or conditional convergent. Okay, so now we continue for the others comparison test. So this one kita akan learn about the ratio and roots. Okay, ratio test and root test. Ratio, root test and ratio test. Root test and ratio test. Okay, so is the convergent absolute. Okay, absolute convergent if the limit set n less than 1. Okay, the divergence if larger than 1 and limit equal to infinity. When you solve the answer, is the limit is the infinity. Okay, or larger than 1 ataupun infinity. So kalau you determine the answer, you limit the answer is equal 1, so this is the unconclusive. That means you need to use the others roots. Okay, you need to use the others test, other test. So they're not suitable to use the root test. Okay, so you need to find the others test and then find either the series is the convergence or divergence. Okay, this is an example. Determine the convergent by convergent or divergent by using the root test. So the root test you kena all here you kena set. Okay, set n. Okay, so the answer and then you limit. Okay, you set n. So this one sama dengan exponent 2n over nn. Okay, 1 over n. 1 1 over n cert is equal to 1 over n. So 1 over n, this one you multiply and multiply, so you dapat 2n multiply 1 over n dapat 2n per n, n multiply dengan n 1 over n, you can get the answer is n over n. So you simplify here, so you get the answer is exponent 2 over n. So you limit to the infinity. Okay, so limit infinity, any constant here, this one the constant. Okay, n over a, this one n over 1 constant, so the answer is the 0 less than 1, so this is the absolute convergence. Okay, this is the way. Just you put the cert n into the series and then you solve the limit. Okay, so this is the limit, so you need to do some revision and exercise for the previous chapter 1 maths 1 to make sure your limits knowledge must be good. Okay, so this one we use this similar root test, so you bring all here and cert over n, so actually 2n plus 1 n, and then you multiply dengan 1 over n. Okay, this is the way. Cert ni sama dengan 1 over n, cert is the 1 over n, so you simplify. Cert is so 1 over n, so multiply 1 over n, so cancel, so the remain 2n n plus 1, so you need to the limit here. So limit here, how to solve limit here, you need to divide by highest degrees, highest n degrees. Okay, so divide by highest n degrees. Okay, and then you can get the answer equal to 2. Okay, equal to 2, larger than 1, so this one is the divergence. Okay, the second test is the root test. Okay, the root test, that means you need to n plus 1, the series n, this one you need to plus 1 and divide by origin. Okay, and then you limit and then get answer. Either the answer is the 1, infinity larger than 1, or equal to 1. If the less than 1, so converges absolute. If the larger and infinity, the answer is the divergence. Is the equal to 1, so the inclusive. So you need to use the others method to find the series is the convergence or divergence. Okay, okay, so this sama tadi, so un ke an similar an for un, so you limit un plus 1 divide by n and get the answer. Sama yang saya explain tadi. Okay, so you try here, n square n2 3n, so this means all the n you need to plus 1. Okay, all the n you need to plus 1. Okay, so you plus 1 here, and you plus 1 jadi ni plus 1, and you need to plus 1, so they get the 2. Okay, you get the 2, and you plus 1, you get the n plus 1, and then you divide the answer between with the n square 2n plus 1 divided by 3n. So this one you bring as the multiplication, so you need to upside down. Okay, you replace, you need to change, so multiply dengan you get the 3n to n square and plus 1, so dia terbalik lah. Okay, the reverse here because you want to multiply. Okay, so and then you simplify and then limits. Okay, so you simplify, you get this answer. Okay, you simplify here and then you get this answer. Okay, this one will expand, 3n plus jadi 3n multiply dengan 3, so boleh cancel. Okay, this one n square 2n plus 1, this one boleh expand. Okay, so you get the answer here, simplify and then you limit, you get the answer 3 over 2. 3 over 2 ni 3 dulu dia bring out dia bring out. Okay, 3 over 2 less than 1, this one adalah convergence. Okay, so you try at home for this question. Okay, try to answer all this using the root test and This one using the root test, this one using the ratio test. Okay, thank you.